For our project, we observed the process of green sand casting at General Foundry in San Leandro, California. Mr. Keith Crook gave us an overview of the process and a tour of the facility. To create the mold, the pattern plate is placed inside of a metal frame. The pattern plate is reusable and made by hand out of wood or with stereolithography for more complex parts with smaller features. The worker puts some crushed walnut shell on top of the pattern to keep it from sticking to the sand. The frame is filled with sand and compacted down with a pneumatic hammer. After adding more sand, a press further packs the sand. The worker then uses a tube to cut holes for the screws out of the sand. The table is then vibrated and the top half of the mold is removed. The pattern is removed and the bottom half of the mold is placed on a cart. The top half of the mold is replaced. Molten aluminum is poured into the mold until aluminum fills the sprues. The mold is moved out of the way and given about 30 minutes to cool. When the aluminum is solid, the mold is dumped on a conveyor belt where the sand breaks apart. Workers then separate the aluminum part. After additional cooling, a skilled worker uses a bandsaw to cut off the sprues, which are melted in the furnace and used again. The part then moves on to finishing, where workers sand off all the rough edges and features which are not a part of the final product.
This sand casting process uses green sand, which refers to sand that is in a wet state in the molding process. Green sand may consist of various ingredients. The amount of each of these ingredients will vary for the mold depending on the type of metal that is expected to be used in the casting process, which in this case is aluminum. General Foundry's green sand consists of olivine sand, bentonite clay, and water, which must remain at a certain humidity for optimal integrity in the casting process. The sand must be used within half an hour to ensure that all the fine details of the mold are transferred. Once the sand is used, a majority of it is reconditioned and reused. The sand that cannot be reconditioned is then separated and discarded. One challenge is that as aluminum cools, it contracts, and the mold can become starved for material. This is solved by making lots of large screws. They act like reservoirs, filling the mold as the metal cools. Another challenge is that the first metal that enters a mold tends to oxidize. This is solved by not having the screws directly fill the part, but fill a ring below the part. The ring traps the oxidation and can easily be cut off.
An alternative method to sand casting is plaster and investment casting. Advantages of this casting process include small part sizes and high dimensional accuracy. It can create thin wall geometry with low thermal conductivity, which prevents warpage. The cost associated with this process is higher than that of green sand casting. Another alternative casting process is no-bake casting. This process is good for making very large parts while retaining high precision. It utilizes more expensive sand mixture that cannot be reclaimed and is therefore a significantly more expensive process. A third alternative is permanent mold casting and is good for clean surface finishes and close dimensional tolerances. This casting process requires a significant tooling investment and is generally viable only for large production runs.
The sand used in precision sand casting has recently become much more expensive because olivine is used in oil fracking. General Foundry uses an automated sand management system. Sand is recycled and reconditioned. Their system mixes, tests, and ensures the sand is an optimal mixture. If the part contains voids or places where the sand wall is too thin, a core is placed in the mold. It is not reusable and must later be broken out of the metal part. The cores are made by blow molding the sand into the cast aluminum mold. The aluminum is heated by a flame on each side to make the resin and sand stick together and fill the mold. After the part is cast, the core material is broken apart and discarded.
We would like to thank Mr. Keith Crook and General Foundry for allowing us to take this tour. Thank you for your attention.